Our sun, a giant ball of burning gas, is not as calm as it seems. It unleashes powerful bursts of energy known as solar flares. These phenomena, called space weather, can impact our planet. Imagine a world without electricity, where our communication systems fail. Understanding solar flares is crucial for safeguarding our technology. Join me as we explore the interplay between our planet and space. Welcome to Astral Archives. Space weather refers to the changing conditions in space, particularly those caused by the sun's activity. It's like regular weather, but instead of rain and wind, we have solar flares, coronal mass ejections, and cosmic rays. Imagine space as a giant ocean, and Earth as a ship sailing through it. The sun, like a powerful lighthouse, can send out waves of energy that rock our little ship. These waves are what we call space weather. Space weather is important because it can directly impact us here on Earth. It can interfere with our technology, disrupt our communication systems, and even pose a risk to astronauts. Understanding space weather is crucial for protecting our technological infrastructure and ensuring the safety of space exploration. Just as we check the weather forecast before leaving home, keeping an eye on space weather is becoming increasingly vital in our technologically dependent world. The sun, our nearest star, is a dynamic and restless celestial body. While it provides us with life-sustaining light and heat, it can also unleash powerful bursts of energy known as solar storms. These storms, often associated with sunspots, are a fascinating and potentially disruptive aspect of space weather. Imagine a giant rubber band on the sun's surface, twisting and contorting due to the churning magnetic fields beneath. When this rubber band snaps, it releases a tremendous amount of energy in the form of a solar storm. These storms can hurl massive clouds of charged particles, called coronal mass ejections or CMEs, into space at incredible speeds. CMEs, like giant plasma cannonballs, can travel millions of kilometers from the sun, sometimes directly impacting Earth. When a CME collides with our planet's magnetic field, it can trigger a geomagnetic storm, a disturbance in Earth's magnetic field that can last for hours or even days. These geomagnetic storms, while often invisible to the naked eye, can have significant impacts on our technology-dependent world, disrupting communication systems, causing power outages, and even affecting satellite operations. Solar flares are sudden, intense bursts of radiation from the sun's surface. These bursts, like cosmic flashbulbs, release tremendous amounts of energy, equivalent to millions of hydrogen bombs exploding simultaneously. Imagine a giant spotlight on the sun's surface suddenly turning on and off. That's a solar flare, a brief but intense release of energy that travels at the speed of light. These flares are often associated with sunspots, regions of intense magnetic activity on the sun's surface. Solar flares, though lasting only minutes to hours, can have significant impacts on Earth, particularly on our technological infrastructure. The intense radiation from these flares can interfere with radio communications, disrupt GPS signals, and even damage satellites in orbit. While solar flares pose a potential threat to our technology, they also offer a glimpse into the sun's awesome power and the dynamic nature of our solar system. Understanding these flares is crucial for mitigating their potential risks and ensuring the resilience of our technological systems. The perils and wonders of solar flares on Earth. Solar flares can disrupt technology, but also create the auroras. They interfere with communication systems. Radio waves, crucial for aviation and emergency services, can be blacked out, but they also cause the mesmerizing auroras. Charged particles from solar flares excite atoms in Earth's atmosphere, causing them to glow. This glow manifests as vibrant curtains of light, captivating skywatchers for centuries. Cosmic rays, mysterious particles from deep space. Beyond the familiar glow of our sun, a constant barrage of high-energy particles bombards our planet from the far reaches of the cosmos. These particles, known as cosmic rays, are like celestial messengers, carrying information about distant galaxies and the most energetic events in the universe. Imagine tiny subatomic bullets traveling at nearly the speed of light, originating from exploding stars, active galactic nuclei, and other cosmic powerhouses. These are cosmic rays, consisting mostly of protons and atomic nuclei, zipping through the vast expanse of space. Cosmic rays are a form of ionizing radiation, meaning they can strip electrons from atoms in their path. This ionizing property has implications for life on Earth, as cosmic rays can damage DNA and potentially contribute to mutations. While the Earth's atmosphere and magnetic field provide significant protection from cosmic rays, some of these high-energy particles still reach the surface, interacting with our environment and even influencing our climate. Cosmic rays impacts from technology to climate. Cosmic rays, high-energy particles from deep space, impact our technology. Their effects, though subtle, are crucial to understand. Imagine a cosmic ray colliding with a satellite's electronic component or a computer chip on Earth, causing a bit flip. This can lead to malfunctions in these systems. Cosmic rays also play a role in cloud formation. They ionize air molecules, creating cloud condensation nuclei. Changes in cloud cover can influence Earth's energy balance and climate. The Northern Lights, a dazzling display of space weather. The Northern Lights, or aurora borealis, are a mesmerizing display of light, captivating observers for centuries. They occur when charged particles from the sun interact with Earth's atmosphere. Imagine electrons and protons colliding with oxygen and nitrogen atoms. These collisions release energy as light. This light creates shimmering curtains, arcs, and rays of vibrant colors, most commonly observed around the Arctic Circle. Witnessing the Northern Lights is a truly awe-inspiring experience. Protecting our planet, monitoring and predicting space weather. As our reliance on technology grows, so does our vulnerability to space weather. From communication systems to power grids and satellites, our modern world is increasingly susceptible to the unpredictable whims of the sun. Protecting our planet from the potential disruptions of space weather requires constant vigilance and accurate forecasting. Imagine a global network of telescopes, satellites, and ground-based sensors, constantly monitoring the sun for signs of solar flares, coronal mass ejections, and other space weather events. This is the reality of space weather monitoring, a collaborative effort involving numerous organizations worldwide. Just as meteorologists track hurricanes and thunderstorms, space weather forecasters use sophisticated computer models to predict solar storms and their potential impacts on Earth. These forecasts provide crucial warnings, allowing satellite operators to take protective measures, power companies to safeguard their grids, and airlines to adjust flight paths to minimize radiation exposure. Protecting our planet from the potential disruptions of space weather is an ongoing challenge, requiring constant advancements in monitoring, forecasting, and mitigation strategies. The future of space weather forecasting. Space weather forecasting is a relatively young science, but it is rapidly advancing, driven by the increasing recognition of space weather's potential impacts on our technology-dependent society. The future of space weather forecasting holds exciting possibilities for improving our ability to predict and mitigate the effects of solar storms. Imagine a future where we can predict solar flares with the same accuracy as we forecast terrestrial weather. This is the ultimate goal of space weather forecasting, and scientists are working towards developing more sophisticated models that incorporate real-time data from a vast network of space and ground-based observatories. Artificial intelligence and machine learning are also playing an increasingly important role in space weather forecasting. These technologies can analyze vast amounts of data from solar observatories, identify patterns and anomalies, and improve the accuracy and lead time of space weather predictions. As our understanding of the sun and its complex behavior grows, so too will our ability to forecast space weather and protect our planet from its potential disruptions. In the grand tapestry of the cosmos, our planet Earth is but a small speck, constantly bathed in the energy and influence of our sun. Space weather, a symphony of solar flares, coronal mass ejections, and cosmic rays, is a powerful reminder of our intimate connection to the celestial dance of our solar system. From disrupting communication systems to influencing our climate, and even sparking the breathtaking beauty of the auroras, space weather plays a significant role in shaping our world. As we venture further into the space age, our reliance on technology only amplifies our vulnerability to the unpredictable nature of space weather. Understanding, monitoring, and predicting space weather are not merely scientific endeavors, but essential steps towards safeguarding our technological infrastructure, ensuring the safety of astronauts, and comprehending the delicate balance of our planet's systems. As we peer deeper into the mysteries of the sun and the vast expanse of space, we gain valuable insights into the forces that shape our planet and our destiny. If you like this video, don't forget to like and subscribe.